Hello everyone, my name is Ahmed Reza Avantgarde and I will teach you how to benefit Ansys Workbench as one of the most powerful simulation and modeling software in engineering application. This course is presented by King's University under the supervision of Dr. Farhan Danishmand. The first lecture will provide you with a brief introduction to application of computers in mechanical designs, and then we will be familiar with Ansys company and its background. As our purpose is to make you ready to utilize Ansys modules for your future modeling problems, we will directly go through practical information about Ansys software's environment, and we will show you how to use appropriate modules for different kinds of problems. Here, I will show you the basics, how to share data among different applications, etc. And in addition, working with files is also an important part of this session. So at the end of this lecture, you will be able to build your first project and understand all the icons, menus, and toolboxes. So let's get started. In this part, you will be shown a variety of computer modeling applications. Here, a radical fatigue test is implemented for a automobile rim by use of Ansys. As can be viewed, the left figure shows the geometry which is prepared for solving finite element equations, and on the right of the screen the von Mises stress is visualized in a way that you can observe the minimum and maximum values throughout the whole computational domain. By the computational domain, I should say that we characterize all the RAM geometry with nodes in which the software will solve equations. Here, we pick a subsystem and make a simulation that shows us the effect of internal pressure from combustion on the top of the piston. Let us proceed. There you go. Here you can see the effect of pressure on a piston deformation. Like solid bodies, we can simulate the behavior of fluid flows for different cases. As you can see here, air flew over two different obstacles is modeled for different Reynolds numbers. The right-hand side figure provides a comparison between computer modeling and realistic experimental results. Yep, we can witness an acceptable consistency between these results that expresses computer modeling is working surprisingly well. Another example is airflow over a wing. The left figure represents a cross-section of the main wing. On the left, the negative and positive pressures can be helpful to conceive the effect of these two factors on lift and drag forces. And here, a peer-reviewed study led by Professor Feng from Oklahoma University investigated the influence of wind on droplets exuded when coughing or sneezing. Simulation demonstrates how droplets travel from person to person in the event of a gentle light, and moderate wind, with and without a mask. So let us see the movie. As another example, a CFD study using Ansys Fluent provided a detailed flow field of a conduit with different sensor tappings for the flow circuit of a ventilator. The animation shows the air velocity and the vortices formed in the conduit enables engineers to optimize sensor locations. Let us see the animation. Yep. And again. Wear a mask. A well-advised recommendation. Masks can reduce the risk of contaminating others by up to 6 times. Adjustments can be made to ensure masks are sealed properly to reduce the risk of possible exposure. Now, let's kick off introducing Ansys company and its software. Ansys Workbench is a project management tool. It can be considered as the top-level interface linking all our software tools. The company, founded in 1970, and benefits from more than 4,000 experts in a wide variety of majors in master and PhD levels. According to Fortune and Bloomberg magazines, Ansys has been recognized as one of the world's most innovative companies. Workbench handles the passing of data between Ansys, geometry, mesh solver, post-processing tools. This greatly helps project management. You do not need to worry about the individual files on disk, like geometry, mesh, etc. Graphically, you can see at a glance how a project has been built. Because Workbench can manage the individual applications and pass data among them, it is easy to automatically perform design studies like parametric analysis for design optimization. To tell you about the historical background, the first commercial version of Ansys software was labeled version 2 and released in 1971. At the time, the software was made up of boxes of punch cards, and the program was typically run overnight to get results the following morning. In 1975, nonlinear and thermoelectric features were added. The software was exclusively used on mainframes until version 3, the second version, was introduced for the VAX station in 1979. Version 3 had a command line interface like thus. In 1980, Apple II was released, allowing Ansys to convert to a graphical user interface in version 4 later that year. Version 4 of the Ansys software was easier to use and added features to simulate electromagnetism. In 1989, Ansys began working on fluid dynamics, the software that was integrated into Ansys by version 5, which was released in 1993. Performance improvements in version 5.1 shortened the processing time 2 to 4-fold and was followed by a series of performance improvements to keep pace with advancement in computing. Ansys also began integrating its software with CAD software such as Autodesk. In 1996, Ansys released the Design Space Structure Analysis software, the LS-DYNA, Crash and Drop Test Simulation product, and the Ansys Computational Fluid Dynamics CFD. And simulators were added. Ansys also added parallel processing support for PCs and multiple processors. The educational product was introduced in 1998, and version 6 of the main software was released in December 2001. Version 6 made large-scale modeling practical for the first time, but many users was frustrated by a new blue interface. The interface was redone a few months later in version 6.1, and version 8 introduced the Ansys Multifield Solver, which allows users to simulate how multiple physics problems would interact with one another. Version 8 was published in 2005 and introduced Ansys Fluid Structure Interaction, which simulates the effect of structures and fluids that they have on one another. Ansys also released its probabilistic design system and design explorer software, which both deal with probabilities and randomness of physical elements. In 2009, version 12 was released with an overhauled second version of Workbench. Ansys also began increasingly consolidating features into the Workbench software. Version 15 of Ansys was released in 2014. It added new features to composites, bolted connections, and better mesh tools. In 2015, version 16 introduced to AIM Physics Engine and Electronics Desktop, which is for semiconductor design. The following year, version 17 introduced a new user interface and performance improvement for computing fluid dynamics problems. In 2017, Ansys released version 18. Version 18 allowed users to collect real-world data from products and then incorporate the data into future simulations. The Ansys application builder, which allows engineers to build and use and sell custom engineering tools, was also introduced with version 18. To put it in a nutshell, in early 2020, the Ansys academic program surpassed 1 million student downloads. This is really surprising for me. Now let us discuss various applications and modules in the Workbench. The first is mechanical module for performing structural and thermal analysis using Ansys software. It is worth mentioning that the meshing utility is included in this module. The second is mechanical APDL, which is used for mechanical and multiphysics analysis through the conventional user interface. The third and fourth modules are the main fluid flow simulating packages such as CFX and Fluent. Another is Design Modeler, which is also one of the essential applications through which you would be able to make your CAD models and prepare your desired solid bodies. For setting and changing the material properties, you can benefit from the engineering data section. Meshing applications would be your best friend in order to make your geometry compatible with your facilities such as computing devices and get sensible results according to how much money you want to spend on your simulation. Design exploration is the best way of making your simulation efficient and get optimized setting for your desired problem. Moreover, modules such as finite element modeler will help you to import mesh constructions from other platforms and use the imported computational domain for your modeling in Ansys software. And finally, we recommend you to learn how to exploit the explicit dynamic module for nonlinear systems modeling. This module won't be covered in this series. Once you open the Ansys software, you will be faced with this toolbox that contains a variety of modules that you may be in need of. The options visible in this toolbox show all the products and systems you have licenses for. The first section of this toolbox is Analyze a System that are ready-made stencils that include all the individual systems and applications needed for common analysis. For example, geometry, mesh solver, post-processors, etc. The next is Component Systems box that includes the individual building blocks for each stage of the analysis. Design exploration provides tools for optimizing designs and understanding the parametric response. Here, dragging an analysis system onto the project schematic lays out a workflow comprising all the steps needed for a typical analysis. The workflow is from top to bottom. As each stage is completed, the icons such as up-to-date, refresh, etc. at the right-hand side will change. Okay everyone, we are at the end of this lecture. I hope you find this lectures interesting and beneficial and use all the information practically. Thank you. Please be safe.